third law states that all forces have to occur as action-reaction pairs, and this can get pretty complicated pretty quickly. Not so much interested in, focusing on the complexity, but it is worth pointing out, and hopefully you do understand it as we go through it. If I gave you a scenario of, let's say, we got a table, and on the table there's, a ball. And essentially I said, we've got all these forces in play here. Let's try to identify them. And so what we're going to have to do is consider the objects here. I've got a ball, I've got a table, and we both know that they weigh something. So the third object that we're going to consider is the planet Earth here. Basically, these are all the objects in play in this scenario here. So if I was looking at the ball, we'll do a free body diagram of the ball. We'll do a free body diagram of the table, which is that. And then we'll do a free body diagram of the Earth. And we'll just label it like that. There's a force of gravity acting on the ball. Let's call it F of G. But who does the application of that force of gravity? It's the Earth. So we're going to say Earth on ball here. It's always useful to use subscripts when you're trying to identify action-reaction pairs. So likewise, there's a force of gravity acting on the table, and that is from the Earth on the table. So we got two different force of gravities acting on here. And essentially, I know that the ball is resting on the table. So there is a normal force acting on the ball, and it comes from the table. So let's call this normal force table on ball. Now, the table is resting on the Earth. So let's actually write normal force from the Earth. And you know what? I'm going to draw this a little bit bigger than my gravity. And it comes from the floor, and the Earth owns the floor, so we're going to call it normal force Earth on table here. And the reason I'm drawing it greater is because I know that there's an object on the table. So I actually know that there has to be a greater normal force acting on the table. And we can actually figure out why that is. And it all has to do with the third law. Because if you think about it, take a look at this force here. I know that it's equal to this force. There's no question about that. In fact, I've basically accounted for all the forces acting on my ball here. There's the force of gravity, and there's the normal force that comes from the table. But the table pushes the ball up. The third law says if the table pushes the ball has to push the table down. So essentially, there's a normal force table on ball downwards, and these two forces are equal. So this normal force needs to not only balance out the gravity, but it also needs to balance out the downward pressure coming from the ball. So this is why when, if you're standing on a scale and you have additional weight on you, what it's doing is it's pushing down on you and increasing the reading on the scale here. So from a third law perspective, this now makes sense as to why the normal force has increased on you. Now that being said, we have some action-reaction pairs to identify here. And I've only done it so far between those two things. Every one of these other forces has to have an action-reaction pair. So the force of gravity is the weird one because you and every other object around you has gravitational pull as well. The Earth doesn't just pull the ball down, the ball is simultaneously trying to pull the Earth up. So there's a force of gravity acting on the Earth that comes from the ball. Let's call it B on E. And then same thing for the table. The table's going to try to pull it up, so let's call it F of G, table on Earth. T on E. It actually looks like bone and tone right now the way I wrote them. And so now what I've done is I've identified an action-reaction pair here. Let's actually, we'll do an oval on these two. And then for this one, I don't know, I'll do triangle. So last one is this. The Earth is pushing the table up. Well, that means that the table also has to simultaneously be pushing down on the Earth. So we're going to have a normal force table on Earth. And this is also an action-reaction pair. And I'm probably running out of shapes here, but you know what we'll do? We'll do like a parallelogram to signify that these two things are action-reaction pairs. So we've identified all forces acting on all objects. Each has an action-reaction pair. The third law applies to everything.